Now I give lecture on power reactors in use. First one is gas cooled reactors. Second one is heavy water cooled and moderator reactors, or another name is CANDU type reactors. The another name is pressurized heavy water reactor. Now you see the diagram. This is the diagram of gas cooled reactors. So in the gas cooled reactors consist of fuel rods, graphite moderator, pressure vessel, radiation shielding, control rods, charge tubes, heat exchanger, water circulator, turbine, condenser and alternator only. Then we detailedly studied about the function of the gas cooled reactors. The gas cooled reactors uses gas. The gas may be CO2 or helium in the place of water as coolant and graphite as a moderator. So in the gas cooled reactors, carbon dioxide or helium gas used as a coolant instead of water, and then graphite is used as a moderator. The main advantages of gas used as a coolant is, first one is safe, second one is easy to handle, third one is heated up to any temperature without change of phase at any pressure. This reactor uses uranium dioxide as a fuel. A concrete sealed covers up the core to avoid radiation leak, and all the essential components are contained in the pressure vessel, in which there are 4 bars of uranium fuel elements wrapped by graphite moderators with a number of charge tubes sticking into them in order to load fuel elements. Now you see the diagram and all, the outside rectangle shape green and all is the radiation shielding. Inside the oval shape green is the pressure vessel. And then inside how many fuel rod is there? 4 number fuel rod. Orange color vertical line represents 4 fuel rods. In the radiation shielding, then parallel to line is there, that is the charge tubes. Inside the charge tube only the control rods are passed through only, that is the black color vertical long line represents the control rods. Then the ash color 4 vertical line is nothing but the graphite moderator. That is the thick ash color 4 vertical bar is graphite moderator. Two ducts run out of the reactor to form a gas duct circle with the heat exchanger. A heat exchanger is necessarily required. Gas is circulated through the reactor core and the heat exchanger by means of a blower or gas compressor. The steam pressure is around 150 atmosphere and the temperature is around 550 degrees Celsius. The tubes in the heat exchanger through which water is circulated should have fins on their surface so as to improve the rate of heat transfer. Then what is the advantages of gas cooled reactors? First one is it has no corrosion problem, because instead of water we are using gas as a coolant. Second one, greater safety in comparison with water cooled reactors, because gases are easy to handle. In boiling water cooled reactors, we are using water is used as a coolant. But in gas cooled reactors, gases are used as a coolant. Therefore, you can easily handle. So, therefore, greater safety in gas cooled reactor. Third one is contamination problems are moderate. Fourth one, these can be operated at a high temperature. Gases can be pressurized easily. Graphite remains stable at a high temperature and radiation problems are minimum. In gas-cooled reactors, graphite is used as a moderator. So therefore the graphite stable at high temperature and radiation problems are minimum. Then disadvantages of gas-cooled reactors. The first one is the large size of reactor because of use of natural fuel and graphite moderator. Because graphite used as a moderator and the natural fuel also uses, so therefore the size of the reactor large. Second one is extremely low power density only. Third one, low steam pressure and temperature. Fuels have to be operated at high temperatures. If helium is used as a coolant, leakage is a major problem. Gases have a lower heat transfer coefficient. It requires large heat exchangers. A large amount of fuel loading is required for gas-cooled reactors. More power is needed for coolant circulation compared to water-cooled reactors. Because in water-cooled reactors, water can be used as a coolant. But in gas-cooled reactors, gases used as a coolant. Therefore, more power is needed for coolant circulation compared to water-cooled reactors. Then we studied about the heavy water cooled and moderator reactors or CANDU type reactors. The another name also pressurized heavy water reactors. Now you see the diagram. The heavy water cooled and moderator reactor consists of control rods, calandria. Calandria is nothing but the pressure vessel, pressure tubes, fuel rods, heavy water moderator. That means heavy water can be used as a moderator, heat exchanger, water pump for water circulation, heavy water pump also we are using, and then concrete is used as a shielding of a reactor core. Now we detailed study about the working function. So this is the, you see the previous diagram, I have to segregate that one, reactor building and turbine building. So the reactor building, what is? Steam turbine, reactor, fuel, moderators, everything is shielding, everything comes under reactor building. The turbine building means turbine, generator, condenser, circulating water pumps. These are is known as the turbine building. So the heavy water cooled moderator reactor diagram is split into two sections. One is reactor building, another section is turbine building only. Now we detailed studied about this is also heavy water cooled moderated reactor, and because the previous diagram I didn't include the turbine and the electric generator. Now here clearly included turbine, electric generator and then condenser. Same circuit diagram only. So the ash colored red color that block is the reactor core, and then heat exchanger. The zigzag one is like nothing but the heat exchanger, and then turbine. The yellow color is electric generator, is nothing but alternator, and then condenser. So these are the main parts: heat exchanger, reactor core, turbine, alternator, and then condenser. So the arrow mark indicate from the diagram, you can indicate the arrow mark. That means what? That means heavy water can be used as a moderator and then coolant also. So the heavy water coolant from the reactor core goes to heat exchanger and then heated, that converted into steam. That steam goes to turbine. The turbine, that means this steam only is used to drive the turbine. The turbine coupled with the alternator. So the alternator converts mechanical energy into electrical energy. The exhaust steam from the steam turbine goes to condenser. It should be cooled, and then again the cooled water, that is the light water, then again comes to heat exchanger, then reactor core, like this. This is the cyclic process. Now we detailedly studied about the function of the heavy water cooled and moderated reactors. The word CANDU stands for Canadian Deuterium Uranium. So the shortest notation is CANDU. Is very important power reactors in use. The CANDU reactor was designed by Atomic Energy Canada Limited. The shortest abbreviation is AECL. Compared to other reactor designs and all, so enriched uranium, that is 2.5%, 2 to 5% uranium 235. The CANDU allows more local input, do not have the capability to cast a pressure vessel. The CANDU fuel contains uranium dioxide with natural uranium. Natural uranium means uranium 235. So 0.7% uranium 235. As a result, the CANDU is very cheaper to fuel and can give higher lifetime capacity factor to the heavy water cooled and moderated reactors. The CANDU design consists of a horizontal calandria. Calandria means pressure vessel, which has tubes for the fuel rods and cooling water. So the heavy water is the coolant. Also, heavy water means deuterium oxide. The notation is D2O. So the heavy water can be used as a moderator, which is used to slow down the neutrons. The heavy water D2O consists of 2 atoms of deuterium, that is D2. That is, the deuterium is a non-radioactive isotope of hydrogen. And then the oxygen O, 1 atom of oxygen. So that's why the heavy water represents D2O. Deuterium atoms represents about 1.5% of hydrogen found in nature. The deuterium is much more efficient compared to moderator than light water, then allowing the use of natural uranium as a fuel. The deuterium separation is added initial capital cost over the plant lifetime by the lower natural uranium fuel cost. The pressurized heavy water reactor. Why the water should be pressurized? That's why this reactor can also be called as a pressurized heavy water reactor. The shortest abbreviation is PHWR. The pressurized heavy water reactor is a nuclear power reactor commonly using enriched natural uranium as a fuel that uses heavy water as its coolant and moderator. In this moderator, unenriched natural uranium can be used as a fuel. Heavy water can be used both coolant as well as moderator. The heavy water coolant is kept under pressure, allowing it to be heated to a high temperature without boiling much in a typical pressurized water heater. So this water heater compared to pressurized water heater, we already studied in the previous lecture video. So therefore the heavy water coolant is kept under pressure, allowing it to be heated to high temperatures without boiling compared to pressurized water reactor. While heavy water is more expensive than the ordinary light water, it yields enhanced neutron economy, allowing the reactor to operate without fuel enrichment facility and generally enhancing the ability of the reactor to efficiently make the use of alternate fuel cycles. The heavy water cooled and moderator reactors used in countries where enriched uranium is not available. Wherever enriched uranium is not available, you can use this type of reactor. The primary and secondary circuits are similar to pressurized water reactors. The coolant heavy water is circulated in the primary circuit and the steam is produced in the secondary circuit, transferring the heat in the heat exchanger. You can recall the diagram. In the diagram and all, heavy water is the coolant and moderator. In the reactor core, the heavy water, and then the heavy water goes to where that means and all, that means heat exchanger, then only heated. So the coolant heavy water is circulated in the primary circuit only. But the steam is produced in the secondary circuit. Therefore, two circuits we are using, primary circuit and secondary circuit is similar to pressurized water reactor. In the case of pressurized water reactor, reactor cooling pump circulate heavy water through the reactor then to the steam generator in a closed loop. The moderator heavy water system has a separate heat exchanger with the circulation system for cooling the moderator. This is the difference between the pressurized water reactor and pressurized heavy water reactor. Then advantages of heavy water and moderator reactor. The first one is simple reactor control can be used in the reactor because absence of fuel rods. The next fuel consumption is low. No control rods are used in the CANDU type reactors. Low pressure vessel is used, that is a CANDU. More effective in slowing down the neutrons because moderator being at low temperature. Here heavy water can be used as a moderator which is used to slowing down the neutrons at low temperatures. Therefore, it is more effective compared to other type of reactants. What is the disadvantages? Heavy cost of heavy water. Heavy water means what? D2O. So, the cost of heavy water is very heavy compared to light water. Very high standard design. There is no problem of leakage. Therefore, a proper safety design is needed. We never used gas. In gas-cooled reactor, water gas is used as a coolant. Therefore, leakage problem is there. But here and there is no leakage. There is no problem of leakage. Therefore, the proper safety design is but no leakage, but proper safety design is needed for that heavy water cooled reactors. So thank you students for watching this lecture videos. From the lecture video you can clearly understood what is the function of gas cooled reactors and heavy water cooled and moderated reactors. These two reactors is the one of the type of power reactor in use. The power reactors is the one of the parameter which is used to classify the nuclear reactors. Thank you student for watching this lecture video.